So welcome again. It's a Sustainability in 6G open lecture organized by 16G. We have a set of impressive speakers today. I'm very honored to be your moderator today, hoping that I will get the questions right and maybe tease some interesting information from our valued speakers. So just for your information, very importantly, all the sessions will be recorded and published on the 16G website. So you should know this. All this is recorded. So if you have your questions and maybe if you interfere, this might appear then later in the official recording. You are obviously welcome to post questions and comments in the chat. Our speakers will try their best to address them. At the end, we will have a Q&A session where you will be again maybe capable of asking one or two questions depending on the time. Otherwise, I have obviously prepared some questions for our speakers that will also be addressed at the end. You can also join the discussions online. You have some hashtags here where you know probably how to do it. And if you have any technical issues, please contact our host at info@16g.org. Okay. So again, I am working as a director for future network technologies at Huawei Munich Research Center. I'm very honored to be here, the host. The interest in sustainability, as you know, has skyrocketed recently. It so far probably was more understood as the non-technical issue discussed in the society at large. But more and more, we're switching also to the understanding that probably each domain, technical or not, must somehow do its best to contribute to the whole picture. And specifically in ICT, which we all know is somehow very critical in the future, the belief is that with the changes, with the decarbonization of other industries, more and more share of the overall carbon footprint will be probably due to ICT. And it would be interesting, therefore, to somehow see how this ongoing transformation of maybe more classical industries to virtualization, to changes of processes where ICT is more and more involved, where ICT becomes a defining factor, where that will again have an impact on ICT, and to understand then from there what ICT, specifically 6G, can do to improve the overall situation. So we all know this effect, if essentially something becomes very cheap, then it's used more, so-called rebound effect, when the resource can be very efficiently exploited and the costs go down, then usually people use it more, which is in principle not a bad thing. This is how economy works. But if, of course, there are some hidden, non-directly attributable costs, like, for example, impact on ecology, kind of perturbing maybe the future generations' lives, then this is not directly visible, and for that we need new approaches. So with this, I hope very much that we will get some interesting insights in what should be done, what can be done in the next generation in 6G. And I'm very happy and proud to present to you Chiara Lombardo, who is a researcher at the University of Genoa. So maybe Chiara, you can switch your slides and introduce yourself, and we are very happy to hear your talk.
Okay. Good afternoon, everyone. Thank you for joining. My name is Chiara Lombardo, and for the next 20 minutes, I'm going to give a talk about envisioning a green 6G ecosystem, challenges, objectives, and pathways. So starting with some background on energy efficiency and the techniques that have been used in the past. Moving on to the challenges of applying such techniques or evolving them for the upcoming sixth generation of mobile communications. Outline some objectives and how some enabling technologies can be used to overcome the challenges. And finally, pinpoint some pathways that we're adopting in the 6 Green project. So historically, energy efficiency in the network technologies has been seen as the ratio between the network capacity and the energy consumption. It comes to show that to improve this ratio, we have two ways, and the easier one is to increase the network capacity. So in the past, we've always often referred to this technique as just throwing bandwidth at the problem without actually addressing the energy consumption component. In the past, there have been several European projects, one of them being Econet, which is particularly dear to my heart, that have proposed more cognitive holistic approaches for exploiting the power management schemes commonly available in computing technologies to adapt the network capacity to the actual traffic load, while at the same time finding abstraction layers for propagating the information on the reconfigurations to all the network segments. This all made sense before what we can call the network softwareization. Because once virtualization technologies, and especially network functions virtualization, have become a reality, and they have been heavily introduced in the technology segment, there has been a, let me say, misconception that these technologies were intrinsically green. And since they allowed to horizontal scale, they were in turn going to reduce the actual power consumption. However, some research efforts proved that this claim is at least context dependent. Some publications that I worked on with my team outline that NFV applied in some contexts, such as the virtualization of the 4G core or implementation of a Cloud Run, did actually increase the actual consumption. These are just two individual studies, but actual figures in the current context are quite grim themselves. The fact that technologies used for 5G, such as computing, are intrinsically distributed and pervasive by nature, cause a relevant increase of computing resources, and as a result of the operating capital expenses and of course of the carbon footprint that these computing resources require. Not to go through all these figures, but I just want to pinpoint the one in the middle, that is the comparison of energy consumed by 4G, by 5G without optimization, and by the optimized 5G, which we can see is still far higher than the consumption experienced in 4G. At the same time, looking at the image on the right, you can see the breakdown of the energy consumed by the network segment, and it can be seen that the major culprits for this increasing consumption are the radio access, followed by data centers and the service core. What are the main issues in the current technologies that cause such a consumption? Well, for one, into the cloud computing scenarios, the players acting on the virtual layers, so for example, the providers of network services, functions, slices, or the providers of vertical applications, they act on resources that are property of an infrastructure. So a physical infrastructure that is used as a service. In this way, there's no way to incentivize the players acting on the virtual layers to use the infrastructure in an energy conscious fashion. They have no interest in doing so, and also they have no means to see how their deployments affect the consumption experienced at the infrastructure layer. And so as a result, this utilization of physical resources from virtual players cause an heterogeneous utilization of the resources. And of course, the energy consumption of the overall system is affected by that. Moreover, the applications in the 5G context and likely in the upcoming 6G need to rely on the mobility of user equipment and to have some components of their applications and services put as close as possible to the user and following the user. So in this perspective, it's hard to do some aggregation and multiplexing operations when you have such a distributed load on a geographical fashion, and it changes constantly. So it would be very, very useful to provide the resources only when and where they're actually needed to avoid wasting energy. But currently there are no tools to do this. However, things are changing. We know that in the last several years, some initiatives have taken place from the United Nations and from the European community to put an end, so to say, to such wastes. And in particular, the European Green Deal has, in a straightforward manner, addressed the ICT sector by stating that digital technologies are a critical enabler for attaining the sustainability goals of the Green Deal in many different sectors. So the ICT as a driver for sustainability in other sectors that are targeted by the European Green Deal. How can it be done? There are several technologies that are seen as enablers for moving from 5 to 6G. And these can also be a good target for introducing sustainability goals in the 6G technologies. If we think about 6G, the first thing that comes to our mind is artificial intelligence. It's a buzzword at the moment, and it seems to be the technology that will bring us from 5G to 6G. Especially because it will allow to deal with the increasingly complex smart networks and service. So complexity at the access part, complexity in the core. And we need, on the one hand, to handle such complexity, but on the other hand, we also want to do it in real time. So artificial intelligence will be crucial for these goals. At the same time, it should be always applied with a grain of salt, because while we are all aware of its power, we're also aware that it's also power hungry. So we don't want to incur in the paradox that introducing technologies to save energy will actually end up in consuming more energy than it is saving. We don't want that, absolutely. SBA, if we want to develop a new generation of mobile technologies, we need to start from what we already have. What we have is the 5G core, is the 5G SBA. We know that it already includes some features for observability, monitoring, and analytics, but they must be extended on the one hand to include the AI and ML mechanisms that we want to exploit to boost the evolution of the technologies, but also to improve the observability and analytics features that will be required to feed such algorithms. So if we think about improving the sustainability of the technology, the analytics need to be extended in the direction of estimating, forecasting, and mapping energy, and in particular, the induced footprint that comes from the virtual layers, as I mentioned before. Aside from the collection of metrics and using them for training AI, it is also necessary to integrate control and management plane functions with these capabilities in order to make it as dynamically scalable as possible. Because we want to rapidly scale down functions that are not used and be able to resume their operativity as soon as possible. And of course, to have these scaling mechanisms in a tight interaction with the power management offered in the physical infrastructure. This interplay, this interaction needs to be mediated through communication means that need to be introduced at these levels. In particular, the current 5G core already has exposure capabilities in terms of the application functions at the vertical level and of the network exposure function in the SBA. These functions need to be extended to be able to support and even renegotiate network slices according to consumptions and computing requirements in real time. So I've mentioned the observability and the exchange of metrics to feed decision algorithms. The interplay between different players and the mechanisms to allow them to interact. What closes the circle is the presence of business targets that are common among all the players in the 6G ecosystem. So common business targets that don't make sense only at the infrastructure layer, but also incentivize the stakeholders acting at the virtual layer. So those that only rely on a limited pools of resources to be energy conscious, to make decisions and apply changes that keep in mind the impact on the overall power consumption of the ecosystem, and what it takes to motivate someone that has no interest in saving energy, someone who doesn't pay the electric bill. Of course, economic incentives, that goes to show. So just to outline for each stakeholder what could be the main actions to move towards a more sustainable 6G. At the infrastructure layer, we need to be able to map the energy consumption generated at the hardware level to the containers, the pods and virtual machines hosted on top of it. The power management capabilities need to be supported and complemented, so to say, by the presence of runtime policies and long-term optimizations that keep in mind the current workload and the potential estimates on the future trends, and the consolidation of tasks where they can be realized more efficiently. For example, on data centers that can rely on renewable energies. For the network platform, it's clearly the evolution of the SBA to permit the interplay between all the stakeholders, and the mapping of the energy efficiency KPIs in terms of that all the stakeholders can understand and consume, and clearly the introduction of AI-driven zero-touch automation for the network slices and the edge resources. At the level of the application provider, it's important to have clearly defined business models that can showcase the mutual benefits of the optimization of energy consumption to all the members of the ecosystems, not only those relying on the physical components. This can be done through incentives and through the introduction of profiling and analytics mechanisms for the actual estimation and the following optimization of the energy consumption. For the ecosystem as a whole, two main points, very broad. One is the achievement of a proportionality between the dynamic and geographically distributed workload and the energy consumption and carbon footprint. And also the presence of incentives to convince all the players to adopt more energy conscious practices. With the remaining 5 minutes, I want to outline how we are putting all these principles in a project that started 6 months ago, that is the 6 Green project. Keep in mind that this project is focused on the network core, because that was the call. We're not neglecting the access because we think it's not important. It's actually the opposite, if you remember one of the first figures I showed you. But for us, the interest is in the core. So what we want to do is to promote energy efficiency for the whole 6G value chain and enable in particular the network operators and the vertical applications to reduce their carbon footprint by a factor of 10 or more. What we want to do is to evolve the SBA in order to boost the ecosystem flexibility, scalability, and sustainability, and to enable all the stakeholders to reduce their carbon footprint by becoming part of a win-win green economy business, as I said before. We collected all the things that we want to do in what we call innovations, and there are three broad categories. The first one is edge agility, so an evolution of the cloud agility concept. It's basically a handover procedure for horizontally scaling across the edge cloud continuum the structure driven events, so information coming from the user, from the network, from the infrastructure itself. For example, as I already said, the presence of renewable sources, the fact that a data center is reaching its saturation, both for what regards computing resources or even footprint targets for the moment. And in order to do that, we need to introduce mechanisms that allow to scale to zero what is unused and to recover it very, very quickly when needed. The green elasticity can be seen as a vertical counterpart of the edge agility, in which these resources are scaled vertically, not only in the sense of we're adding more resources, but also we're we're dividing the latency budget among all the involved stakeholders. And we're relying on hardware acceleration to elaborate the data in a way that is the more convenient for that particular context. Finally, the energy aware back pressure is what closes the circle for us, and is a collection of all the analytics and the business models that can be derived from these analytics and can involve all the players in the ecosystem towards what we call decarbonized service agreements. So like also the consumption information coming from the infrastructure, so not only computing. For the control plane policies, the presence of new APIs for applying the information, the decisions coming from the AI. Again, these are brand new functions based on Etzieni that will make the decisions and the operations according to information coming from the infrastructure, the network, and so on. And for the management, same as for the control plane, we aim to extend the decisions applied according to the outcomes of the AI policies. And finally, a new set of functions that we want to introduce for the straightforward management of the edge cloud continuum. So also dealing with the abstractions of resources that are owned by different entities. And the extension, of course, of the exposure layer to make sure that everyone receives the same outcomes and they is able to make decisions and drive these decisions on their own. So very quickly, how does it work? Information is collected by the observability functions and the edge cloud continuum ones. They are fed to the decisions that are AI powered. And these decisions are actually applied by the control and management plane functions. To quickly wrap up what discussed so far, we are aware that the adoption of virtualization paradigm has made the mobile networks what we know today, and it has paved the way for applications and that wouldn't have been possible otherwise. But at the same time, the fact that these technologies are extremely distributed and pervasive has caused a relevant increase of the computing resources and, of course, of the carbon footprint and the energy requirements that are a consequence of operating capital expenses increasing. If we want to make sure that the upcoming 6G will be more sustainable than its predecessor, we need to introduce new foundation paradigms since the get-go. So now is the right time to think about what we want to do to make sure that energy carbon footprints of the overall ecosystem does not go out of control. So to this end, we think that it's mandatory to ensure that all the stakeholders involved in the 6G ecosystem are involved in joint carbon footprint and energy efficiency targets. Because without the cooperation of all the players, it will only be a target of the infrastructure and it won't be long-lived. This can be done by promoting greener behaviors thanks to the introduction of green business models and providing the technological means for all the players to have a say and cooperate in making the right decisions for the core sustainability of the ecosystem. And that's it. Thank you very much for your attention, and I leave the floor to the next speaker.
Thanks a lot. Thanks a lot, Chiara. That was very interesting. Interesting project. Thanks a lot, Six Green. Just started beginning of the year and really looking forward to hearing your first results and insights. Okay, from there on, guys, if you have questions, please put them in the chat. We have the Q&A session, which is open always. You know this, in the Zoom application below, you will find the Q&A part where you can just write your questions and they can be answered asynchronously by speakers. So please do this. Do not hesitate. Do not wait. And with this, I'm very happy to switch to Christian Maaßen for the next talk. Christian, the floor is yours.
Yeah, thank you very much, Artur. I hope everyone can see the presentation I'm sharing and trying to explore with you basically the question if our next generation networks, starting with 5G, now going towards 6G, actually also enablers of green in the whole, and share with you some experiences we have as partner the Datacon responsible for hyperconnectivity. We talk a lot about with different industrial users, not only with telcos, about the impact of these new technologies. They might be seeing, they might be gaining if used right. And also, of course, answering then the question, what is right, across the different domains. So this is basically a summary of what we witnessed so far. So when we start, what is what we saw basically with all the ICT progress being made. As with the past industrial revolutions, it always brought us quite some positive progress on the technology plane, helping us with productivity and so on, but also always yielded a kind of negative impact as well. As we see also right now with ICT and more of it being installed, scaling up consistently with digitalization requirements, and having to deal basically with that legacy by now, that with the success of the digitalization, that's a trend we will just see growing. And we don't see it slowing down, rather increasing in speed. So we have to cope with the challenge that the digital transformation is happening and even accelerating, and still having to deal as well with the sustainability issues we are facing on a global scale. So we also try to aim for the future use of ICT also as an enabler to help us and the society, also making the best of this industrial revolution basically on these two planes as well. So that we don't have only the positive aspects, as you can see on the left side, which came with each step we had, and especially with the last one we had now with the fourth industrial revolution, but trying to reduce or offset as good as we can the negative anthropogenic impacts we're seeing as well. And not only the impact the ICT domain has on its own already, with all the numbers we can find, for example, on the CO2 greenhouse emissions being between 2 or up to 4%, depending on the study, of our overall emissions we see on the global scale. So that's why we are also very fond of the initiative, one started at the University of Bonn. We're also working very closely with the researchers involved in it. But these two aspects and trends, basically big challenges we have in front of us, are kind of the same agenda in the end, because digitalization and sustainability go hand in hand and have to go hand in hand to make it work. And that's what we would like to show you in the next slides then. How we also see that happening at the moment and how it can be actually used as a positive in the end rather than a negative. And that when also companies nowadays, even the telco industry, the manufacturing industry, wherever talk about digitalization, they at the same time talk about sustainability or vice versa. So that also these functions we see in the different C positions right now, which might see quite distinct, actually always working towards the same goal from our point of view. So what we see right now, rather coming from the aspect of, what is our telco equipment, our ICT equipment basically contributing to the whole equation. So we heard it before in terms of energy efficiency, in terms of power consumption, of course, the CO2 emissions, also in regard to it, as well as when we see all the e-waste just piling up, the faster and faster life cycles of the equipment, and a circular economy advances still lacking in certain regard, so that we can actually reuse most of it. So still not helping as well with the excavating digital division we see on the globe. And in most cases also missing a cohesive climate action plan or strategy, how to follow up with a 1.5 degree reduction goal we're having at the moment. So as the forefront players or industries, we think that telco has a great need for a data-driven and sustainable transformation going hand in hand with digitalization. It actually enhances. So in the next few examples, I think which are very clear and obvious, it's really talking about then green ICT. So what can they do? As a telco provider, in the end, it's basically upping the game in terms of efficiency of the equipment used, as we also see in the manufacturing plane and anywhere else, how to make the best of what you already have without just building on top of it for more and more capacity. So the question is, how can we actually utilize the different frequency bands, for example, most efficiently? Are we able, for example, to deactivate the highest frequency with the highest impact of energy consumption then in terms of low loads and so on, which can be, of course, extended also to other bands consecutively until the end, if there would be no demand at all, really falling back to a standby and low power mode overall, with a requirement, of course, for fast reactivation. But also here, the interesting part is that's always a reactive game we are seeing at the moment. It's faster and faster reaction, and very impressive also how the recovery structures and functions look like at the moment. The vendors are building and are already putting in the field or having in the field to be used and operated. But where we think we can learn also from other domains is, for example, when we have a look in the energy domain. So we're talking also about huge connected networks there and a constant demand, a constant shifting demand for energy from households, from industry, from transportation and so on. And they know that story quite for a while. it was always that they had to react with their supply of energy from power plants. Nowadays, they are more and more involved on the demand side management as well. And that might be something also with the right frameworks and APIs. Also from the telco side, we could look into way more. So how do we, when we have already all the equipment, like on the left picture here, for example, or the radius of the frequency bands, how do we maybe also attract usage in the times when it's not used at the capacity it could be used? So that it's basically also trying to involve the customer side in the end and offering them with maybe only 2 of their frequency layers instead of the 3 we have here. Always an option to get what they want and maybe to shift the demand in bandwidth, the demand in connectivity to other times where it's more prudent. Basically, as seen in the energy situation we have today. Just to give you a short overview of what we saw, also in regard just of basic shifting functions that we have it now. We see on the left side this deactivation potential we have as now. So with the darker blue shade basically indicating just deactivating one of the carrier frequencies or signals, then the base station or the cell. So where we see that 42% of the carriers have a potential in doing that in low traffic times. And without any service indiscrepancies or something like that. And that only 1/3 of them cannot deactivate anything at all because they are always kind of at peak loads already and don't see any potential to do that. And we have basically 25% which are in between the situation. They think they can go even lower. Also with the modern equipment they have, deactivating also 2 or 3 of the frequency bands they are operating. What you can also see, it's of course a dynamic game. It doesn't look the same each hour of the day, as we all know. So it also has to cater basically to the daily distribution of required connectivity demands. And that's a completely different story also to be able to adapt to that as well. Maybe to foresee it and as already introduced before, maybe to steer it even in that direction so that it's even out to a certain extent. And trying to reach the overall equipment efficiency also here, as we know it as one of the key KPIs for other industries right now. But that's only one part of the story when we're talking about it. So that was all about how do we make basically what we're running in the industry greener in the end. So the direction is still followed. There are gains. We saw them in Barcelona. We're going to see them next year then as well. But the question is, how do we measure it up to the overall sustainability goals? And in order to do that and compare it actually, what do we compare them to if we want to make progress in one way or another? So we can follow the ESG management principles, we can follow the European taxonomy, for example, but in the end, what we found, we have to go to the basically highest framework we all know and agree to, the Sustainability Development Goals, for mutual understanding and comparison. To also actually rate and follow the performance in terms of efficiency gains we're making. So from there, we are going for the ICT for green direction, trying to evade the disruption of locality, trying to foster the circular economy and also improving energy efficiency by all means. As we would do with other movements we saw of digitalization like Industry 4.0, for example. So one of the main goals at the first stage is always transparency. With that, you can optimize the systems even more and try to reach more resource or energy efficient states. at any given time, and also react and shift to them faster than you would have been able to before. It's especially crucial, as I mentioned before, we see the industry growing, and we see it already with 5G. We see that all global carriers are rolling out 5G on the consumer side. But the interesting part is, especially from a telco perspective, now we see basically new kind of operator layer under that appearing with the private networks. And this is just a consideration of one of the many studies showing us how we see it peaking. So we will see many more networks. So basically the ICT network plane increasing significantly on a before not seen layer as we had it. Also just showing an example in Germany with the industrial sites, which could register at a certain frequency and apply for a license privately as well, is already doubling year by year. And with the overall potential just loosely estimated in the tens of thousands, and we think it's even higher, as we will see the private networks in the next decade popping up basically everywhere we go. And this comes as no surprise, since we know that for digitalization, we need basically this full stack to be operational. That's when we talk about end-to-end use cases, because we always have to close the gap between the operational technology side and the information technology side and the enterprise applications and so on, or the platforms we have with all the services behind it. And in between, we always have the connectivity layer and the data processing and analysis, which is either on edge or cloud in a hybrid manner. And so have always this layer as an enabler for anything else. If you want to have more sensor data and basically have a rule-based engine, automate our shop floor in a factory, in a warehouse, or even on a hospital, we always have to consider that part. And that's why it will be growing and will be still a vital part. Without this and established right, we won't be running the whole digitalization potential at all. So this is why we see, also when we think about sustainability, as well as the progress and advances in digitalization, we always have to put this end-to-end thinking and the end-to-end architecture in place, whatever kind of use cases we are aiming for. And as shown before, that's a kind of configuration game we're having on a big scale and on different cascading levels, actually. Because we have, if we do it small, we might have one factory building or something like that, where you have different applications running with automated, semi-automated, or not yet. And then on that side, you might have several of these, with these lines, with these buildings, and so on, where you could have your own private network, but at some point you have to go to a public one. At the same time, you have then to decide what mixture is the right of you. And these are just three main variants we're talking about going into it, and trying them also to cater to the other layers, where just put your data processing as another one, since we try to decide the edge cloud game, which is relevant for each individual use case. And now we're talking about the next generation of networks where we're coming in. What we see also already right now is always the big question, so what should we go for this connectivity layer alone? I already figured out the others, or still have to figure out how they fit together. And we have more and more even coming up, on not only with the players we already know in the game, from the cable-bound solutions even, still is an option, to some low power wide area networks, as we have with Narrowband IoT, LoRaWAN, and so on. But also in the short range game, up to the other players we see right now with low and mid-band 5G, as well as the new 5G, the Wi-Fi generations, and already looking to the new radio applications with the higher frequencies in 5G, and new satellite, non-terrestrial bound communication. And that's actually what we see and expect also with 6G to happen, that this interoperability has to increase as well. So that we find always the best solution. The best solution might not only be the one with a peak performance, but that in that target system, we're looking for maybe also the sustainable KPIs we have to define, so that we make also a crucial part of a decision on what kind of connectivity on demand we're providing an asset and user and so on in each situation, wherever he is. So always as required and maybe even incentivized according to what's available in the end. So that we make the best use also of the new generations of mobile networks to come. So with all of their also more impressive abilities we're expecting right now, and this is just a loose collection of what many associate then also with a new standard, for example, and as well as the ones still in some point to being realized, the 5G with the upcoming releases. And always trying to figure out, is more than always better? And that question to be answered in the real use case scenario. Because we saw, for example, there are not that many very low latency use cases with 5G at the moment. So it's good when a new standard can push that limit, but it should be only utilized to that extent, and also equipment providing that if it's really beneficial and the actual situation where it is used. So always having really on-demand connectivity, that's what we would advise to aim for. And in order to compare it, having basically also global frameworks to work on, which are discussed also on global level, like the ITU with the L1480 at the moment, the standard. We also took as part of a framework they developed and trying also to contribute closely to this new global standard, so that we can actually measure and compare what is the impact of whatever connectivity solution we bring to the table, or an ICT solution, trying to boost the digitalization in whatever domain. So it's always about identifying then the right context in that use case, in that scenario. Might be in a smaller system, like in a machine line, might be basically also a whole factory site or supply chain, where something new is established, like a network. So not only knowing its components, the RAN infrastructure, the service, and so on, but also the dependencies with other technologies and the impact on them, the boundaries set by it, and crucially also excluding components which doesn't belong in the context, because it wouldn't matter if I use that or another technology, so that we can use basically the right baseline, the lifecycle analysis of either the status quo as we have it now, or another technology we want to compare the new one to, so that we really have an idea of what are the avoided emissions, but of course can be also recalculated for energy savings and so on. And where we think it's crucial to consider not only the direct one-to-one comparison, for example, of the components with the LCA, so that would be primary effects, but also what do they yield? If we, for example, put in a new 5G network into a factory, replacing or adding to the status quo we're having, it might give me the chance for operating AGVs with their automatization potential. I have maybe certain gains or reduction in resources and their utilization. And then we have to ask the question, that's the tertiary effect layer, what do we do with what we gained? And a secondary effect, which is related to the new component, but opening up even more potential. And as we also heard before already, in what regard is it used, or is it just a rebound, so that we do more of the same and basically cancel out what we could have actually saved in the end? And while doing so, doing it on a wide scale, learning basically what are the impact measures behind it, what are the levers we can still use to boost these effects always to the positive side, and learn which ones to reduce the negative impact they might be still having. also to have a big library of that, which everyone can access and utilize on a daily plane. And this is just an example when we did it in a warehouse scenario where 5G is the new connectivity layer being established in about a warehouse of 100,000 square meters. And in the end, considering all of the effects which came into play, coming even to a net avoidance of CO2 emissions in that scenario compared to the status quo they had of about 15%. And we think that's quite impressive to see that, also considering that you can take it into your decision and your procurement process and so on, and not only do it by gut feeling, that choice, or just by comparing one radio station versus one access point or something like that, but do it really on the whole game where the impact is actually performed. And that's the tricky part, I think, to have that kind of transparency, to do it together with a lot of stakeholders working together. And that's what we are aiming for in different research endeavors right now with partners, as well as in other parts of our daily work. And I'm very curious if you might have any questions. I must open the plane if there were some I could answer directly, or do it later via the chat. Thank you.
Thanks a lot, Christian. Thanks a lot for this very nice talk. Finally, some numbers, very, very interesting to see. I'm quite sure for all the researchers gathered here, and also for all the people who will see the presentations later online. Thanks a lot for these concrete numbers where we can see, you know, the potential and what and where can be spared. Thanks a lot for that. We're running a little bit late. To all audience, please bear in mind that all this is recorded and will be made available online later. So you need to know that all this is being recorded right now. And with this, I'm very happy and very honored to switch to our next valued speaker, Lubcho Jergozewski. I hope I pronounced the name right. Lubcho, the floor is yours.
Can you hear me now?
Yes, we can hear you. It's all fine.
And also, is the screen visible?
Yes, it's all fine. Floor is yours.
Thank you. So welcome everyone, wherever you are. Thanks, Artur, for this invitation. It's my pleasure to be here and present some insights. Actually, first, let me start with my introduction. I'm a senior wireless consultant in TNO, and I've started already in the transition between 2G and 3G. Now I'm working on 6G, and maybe with 7G I will retire in my professional career, so I will make the whole journey. And it is also my personal motivation to make the next generations as energy efficient as possible and as sustainable as possible. So before diving into the content, I will make a kind of opening statement. So I will talk about green wireless or sustainable wireless network, and I will not talk about using these wireless networks for the sustainable and green world, because the second part is also very, very important. Look at us now. I mean, by using communication means, we have this online lecture, and we have a particular carbon footprint, but this carbon footprint will probably be much more higher if we organize this face-to-face and we had to travel with 60+ participants and have the lecture. So, okay, how the talk will be structured. Very short introduction about TNO, because maybe participants do not know what TNO is. Then I will present NGMN's Green Future Network projects where I'm involved. After that, I will present 3GPP related standardization work that contributes to these green wireless systems. And I will wrap up with some outlook towards 5G advanced and 6G. And I will probably not have time, because we're running late a bit, to present these other activities where TNO is working. So first about TNO, like a small apology for the slide, it's too crowded, but Just to present it briefly, we are the Dutch Research and Development Institute, already existing for more than 90 years. We were founded by Dutch law, and in our statute is written that we are an independent organization that gives objective and scientifically founded judgments. So this is our role, independency and objectiveness. And we have an important mission to connect people and knowledge to create innovations. And this is also the origin of our motto. You will see it everywhere, innovation for life. But this innovation needs to strengthen the competitiveness of the companies and also contribute to the welfare of the overall society in a sustainable way. So this is really a key part of our mission. At this moment, we have divided 4 major societal challenges. So first, safe and secure society, healthy society, sustainable society, and digital society. And then these number 3 and 4 are very relevant for the talk today. As an organization, we are non-for-profit. From the figures from 2022, we are having around 90 million euros of revenues and 3,900 people employed. We are organized in 6 units, and I'm coming from the unit ICT strategy and policy. All right, so let's go towards the NGMN. For the people who do not know what NGMN is, it's an industry forum. You can also check their website, it's ngmn.org, and TNO has there an advisory role. And NGMN as an industry forum and all the stakeholders are picking up on important topics and are creating projects of that around it. So this Green Future Network projects was really high on the list, and it is still a very high priority for NGMN. And the main question is why it was started at all. So I try to illustrate this with this sustainable and enormous growth in mobile data traffic, which I depicted here from this Ericsson Mobility Report of November 2022, and making it links to the sustainability and sustainable growth. So this link is under tremendous strain because let's see, we are here 2023, and let's say in 3 years from now, we will have double the traffic that needs to be supported in the mobile networks. So imagine this, make a parallel which I typically do with just a regular traffic of people and goods with cars and trucks. So imagine in 3 years from now, in all the roads around you, twice as much cars and trucks, etc. If we say one car is one data packet. So this is a tremendous growth. So that means you need to invest a lot in the infrastructure. So you need to put like new digital roads, meaning new frequency bands, new base stations. And you need to take care that these packets, when traveling from source to destination, use as less energy as possible. Because otherwise, if you have like twice as much vehicles, you need to consume twice as much petrol or electricity if they are electrical vehicles. So this is a real necessity. So we cannot go around it. Second very important motivator is money, as always. So making the networks more sustainable and more energy efficient just saves you money. We also saw in some of the previous presentations how a big part of OPEX is the energy consumption. But also, I think more and more it will influence your customers, because customers are getting more and more aware and maybe picky about the sustainability of different businesses, and then you might lose customers. All right, so NGMN started already like 3 years ago working on Green Future Networks, and this project has actually 3 main sub-projects. So each project also publishes regularly white papers. These are readily available on the NGMN webpage, so you can just download them and check the details. So the first sub-project that I want to share with you is the sustainability. So it's already published its first white paper in July 2021, where some challenges were identified for sustainable initiatives in mobile networks. Then in the same year also it was shared with the public how to make network equipment eco-design, how is the end-to-end service footprint. And this year in January, the white paper focused on processes like circular economy, supply chain sustainability, etc. So I will encourage the audience to read and download these papers because of many useful information. A second important sub-project is the metering sub-project. So basically, how metering should be done for sustainability and what kind of KPIs and target values we need for green network assessment. Again, very useful because without metering, you are practically blind and you cannot assess or improve things. Me personally, I was working mostly on this energy efficiency sub-project. We already have one white paper from December 2021, where we are also planning now, we are entering the so-called phase 3 of the project, where we are going to publish in this year and next year updates of this white paper. And we are focusing on the what are the solutions for lowering the network energy consumption. And this is what I'm going to focus in the next few slides. First, let's see where are the high potential or where we can save a lot of energy. So if we make like an analysis for a mobile operator and check the relative usage of energy, we see that overwhelming majority, around 73%, is in the radio network. The rest is for the core and data centers. So it's a logical thing first to start and address the radio access. So if we now zoom in a bit further, and this radio access is mostly on the operator side, the base station, we see that in the base station power consumptions, there are two major kind of areas where energy is consumed. So 40% is already going into the air conditioning because these circuits needs to be kept on a working temperature, and roughly 50% of actually 50% of the power consumption is for radio processing and baseband processing of the radio signals. So no wonder then that we addressed in this white paper some techniques, for example, about energy efficient cooling, and also energy efficient hardware and as well energy efficient software functions. Because we don't have too much time, I will only give some highlights on the energy efficient software functions. And you are again welcome to download this paper from the NGMN website and look at the details in the other areas. So what does it mean, energy efficient software functions? So basically, how to make the base station more energy efficient when transmitting the signal. And how do we usually do this? Is the base station goes to sleep, so taking a nap, either a very short nap of microseconds or a bit longer naps, and it can go even down to carrier shutdown. So you are really switching off a complete frequency carrier if, of course, the traffic level allows it to do so. Because when operators are using these energy efficient techniques, there is always a careful balance with the service quality. So what all these energy efficient software functions are doing is they are impacting the so-called power versus load profile of the base station. So I try to illustrate that with a simple graph here. So in the horizontal axis, if we depict the load, which I also call here PRB utilization from 0 to 100%, and so from 0 to 100% load, and on the vertical axis from 0 to full power consumption of the base station. These sleep modes are just pushing this envelope down, and making it more scalable, so the power consumption follows the load profile. And ideally or desirably, you should push it as much as possible down, and especially in this lower area, which is the goal is the so-called zero load, zero power consumption area. And yeah, industry is really heavily working on that. To make the bridge towards the 3GPP, all these functionalities are also facilitated by the standards, because the base station needs some assistance from the mobile terminals to do this. If you do, for example, carrier shutdown, you need to inform your neighbors. Maybe some load needs to be taken from you and carried out to a different frequency layer or to a neighboring base station, etc., etc. So 3GPP is really working hard on making wireless more energy efficient and green. So just like a few highlights to say that the 3GPP work on greening started already with 4G. One example is this carrier or site shutdown functionality. And copy and pasting here one analysis we actually contributed from TNO as representative of the operators of the KPN. That with a simulation of 48 sites and with 4 carriers, frequency carriers each, if you don't do any carrier shutdown, the consumption will follow the daily profile of the traffic as depicted here. But if you do this in the optimized way, by keeping a given performance target, simulations show that you can really gain a lot in the energy consumption, which is represented with these light blue bars, and these white figures in each bar represent how many sites remain active and how many carriers per site in order to satisfy this performance target. So even from release 10, 4G, this was continuing, and 3GPP set this through towards 5G with the so-called lean 5G carrier design, meaning that some signaling overhead was revisited in order to do not transmit continuously in the air, and also the actual structure of the 5G carrier is made more flexible and more adaptive in order to switch on and off carrying components, such it better scales to the traffic. So just a very recent activities that I want to share, and just for the audience to have a look. I'm not involved in all of this, just to say to you where the 3GPP is heading and what is going on at this moment. So I will start with Run 1. So this Run 1 is a group that really standardized the physical layer, how the actual RF signal looks. And in this work on study on network energy saving in new radio, so this is for 5G, and in this document 38.864, there are many solutions proposed in time, frequency, spatial, and power domain. Again, pushing this kind of power versus load profile into the desired regions. So mostly towards zero power consumption at zero load. And definitely these impacts on the service quality is also assessed. Another interesting part is in SA1. SA1 is like maybe on the other side of the whole OSI stack, just responsible in 3GPP for setting the requirements and the use cases for the 5G system. So in this work on which is captured in this technical report 22.882, the 3GPP is looking how to deliver services with energy efficiency or energy consumption as a service criteria. So I copied and pasted one figure from this document. It's still work in progress. It's updated. So for example, 3GPP would like to have more possibilities to, for example, if you have different slices that are defined and supported by the 5G system for different applications, the 5G system should be able to communicate what is the energy consumption of each slice. Maybe for particular verticals, this would be vertical user, this would be of importance. And then some measures can be taken either to further optimize the slice or to do some checks whether something has gone wrong. Even in the subscriptions are here, SA1 is working that you might have some energy consumptions related limitations in your subscriptions, not only on data, for example. So again, please have a look, tgpp.org, and if you search for this document, you will download the current work. And then finally, because also looking at the time, I will just give a brief look into the future. So towards 5G advanced and 6G, basically greening or sustainability is really high on the agenda. Actually, for 6G is one of the most important pillars and design criteria. But we are going to face several challenges, and I want to highlight 3 of them. Just to share with you what is coming. So first, the whole trend of disaggregation and virtualization of the RAN. So currently we have like a mostly classical architecture when everything is in one base station container, and then you can monitor the energy consumption and you can do some optimizations. But if these modules are distributed, some of the sites, some of the edge clouds, some maybe even further in the cloud, then you need to maybe revisit this optimization and also revisit how are you going to monitor this energy consumption and how you will make this energy consumption information readily available. This is one important trend and a challenge. Another 2 challenges, more towards the beyond 5G, 6G work. So we all know, and it was also mentioned in the previous presentations, that artificial intelligence is coming. It will proliferate throughout the system. It will be at the terminals, at the core, at the base stations, the distributed edge clouds, and there will be also sensing as a new paradigm opening. So it's not just the system for communication, but also for sensing, or usually people talk about joint communication and sensing, and all these requires a lot of energy for processing. So we will have energy consumption optimization challenges, including AI and sensing. And the last challenge, because also due to this disaggregation and multi-party or multi-tenant kind of system architecture, it will be very important that we find a kind of structured and standardized way how we will make this visible from the end to end. What is the energy consumption and carbon footprint for the communication or sensing services, or even AI as a service is also envisaged. So these are the 3 challenges that I want to use as a wrap-up. So, and then I would like to just thank for your attention, and maybe some questions maybe at the Q&A session. I would be really happy to answer. Okay, thank you.
Thanks, Lubcho. Thanks. So very exciting, guys, for all of you who have not yet seen this fantastic NGMN work. There are very interesting statements and a nice structuring of the work. I really appreciated this when I first came across this. Thanks a lot, Lubcho, this insight.
Thank you.
With that, again, I remind everybody in the audience, you can ask your questions. Please profit from this time that we still have this amazing set of speakers that are here today for us. Ask questions online, they will be answered either online or during the talks. And with this, I switch to Monique Galisti. Thanks, Monique, for being with us, and the floor is yours.
Good afternoon, everyone. I hope you can hear me well.
Yep.
Great. Now I will open, I will share my slides with you. I can share it now. Great. Okay. Can you see it?
Yes. Okay,
great. So first of all, my name is Monique Galisti. I'm the president of a non-for-profit association that is called Digital for Planet. And today I will tell you a little bit more about Digital for Planet, but also about a few things that directly concern early requirements on 6G developments in order to make sure that we build sustainable next generation networks. So first of all, Digital for Planet, as I mentioned, is a non-for-profit organization, and we support the development and adoption of green technologies and solutions for the sustainable development of our society. And we are an open network. We work with a variety of organizations, public and private, and with individuals, in order to promote their research and innovation plans and projects, but also in order to connect the dots, to help them exchanging knowledge, tools, gather together. We organize regular webinars, and also help researchers and innovators to identify funding opportunities for their project. We are involved in several Horizon Europe ones, and actually in the latest months, it's been a quite intensive, let's say, acceleration of some of these activities. As I mentioned, we are in several projects, actually 6G NTN, where we're looking at sustainability aspect related to, in particular, satellite non-terrestrial networks. Then we are in Spirit, where we focus more on remote networking technologies. And we will start in a couple of months COROB, in which we're looking at how to make sustainable technologies in robotics and advanced AI settings. Well, the key question is that we have been talking, and we have been hearing a lot of what it means to build sustainable technologies, to build sustainable networks. And there are challenges that relate more to the technology aspects, but there are many other challenges which relate to the boundary conditions, to what needs to happen for those technologies to be greener and to enable greening our planet. To pave the path to sustainability beyond the buzz and beyond the many, let's say, high-level discussions that we've heard, what we believe, and also this can be found in a number of recent reports, its key is create better awareness about the impact, negative and positive, that technologies, and in particular 6G, can have, and educate people in changing their mindset, changing their habits, but also understand how to create technologies that are by design more sustainable. Clearly, another key ingredient is financial means. We know that at private and public level, investments on green digital technologies and also on the development of network technologies that are greener is growing, which is essential. And of course, we need technologies. Technologies that we have heard today should become greener by design, should be affordable and accessible to all in our society and across several vertical sectors, and that should be trustworthy and secure, which are two essential values for the technologies we want for our society. But it's also true that there are a number of mechanisms at business level that must change in terms of enabling greener technologies to better penetrate the market. Clearly, a lot of work is being done and has been done, but a lot more will come on policy-related matters and regulations, but also on standardizations. Open standards are also playing a key role, and as well as open source and open hardware technologies. And together with this, a national and international European level, what we believe is essential is to provide the appropriate fiscal incentives for embracing greener technology. And clearly, what it's very important and it's essential is to have a mindset that goes beyond the border kind of view, because clearly it's something that must become global, and therefore we are trying to also embrace initiatives that are looking at how to globally enforce a number of key aspects to achieve sustainability. When it comes to technologies, so now today let's focus more on technologies. What we know is that technologies, in particular digital technologies, have a great potential across several sectors. They can provide access to essential and also not essential services also for remote locations. They allow optimization of processes across several supply chain, across several vertical sectors. They help better monitoring the environment and also intervene in a faster way for in case of emergency and disaster situation. And in general, they allow to plan and optimize resource consumption. However, we know that technologies are driving electricity demands. They are damaging the environment in their production and in their deployment, particularly in their production, and also in their disposal, thinking about e-waste. And clearly from a, let's say, a cultural and societal point of view, they induce very often overconsumption. Replacing instead of repairing is too often the current common paradigm, and this must change. Now, when thinking about sustainable 6G networks, I think it's essential to realize that we have a unique opportunity because we are in the very early stage of their development, but we know that they will be the skeleton of our future digital society. In this respect, as I already mentioned, they must become sustainable by design. And here there are several aspects that are about how they are manufactured and how they operate. And clearly they are interconnected to a number of other technologies, and therefore it's important to address this issue, this challenge in a quite holistic approach. Now, clearly also the 6G network, 6G technologies must be the drivers and must be the enablers for improvements in sustainability across verticals and for all private and public organizations, including individuals. In doing so, what is very important is to take into account, to be able to monitor, to measure, and therefore control the direct and indirect rebound effects. What are the rebound effects? Probably you all know what they are. They represent these, let's say, primary and secondary negative effects from the adoption of technologies on the environment. We believe that 6G networks must, by definition, deliver societal and environmental values. So beyond economics and beyond the technology KPIs, what is very important is to measure and assess what kind of value do they bring to the society and to the environment. And this debate, it's open in the context, for instance, of the 6G Smart Networks and Services joint undertaking. It has taken more and more prominence. And this goes along with what I mentioned previously, that is about creating a new business model. And this is essential at European level also to ensure technological sovereignty and leadership, especially because there are key values that we give for granted as Europeans, but they are not given for granted, and we should make sure that they are valued, protected, and promoted, such as openness, inclusion, and sustainability, last but not least. And this is also very important in order to make sure that Europe can stay in a competitive position in a global perspective. Now, what is expected from 6G and what we would like to see with 6G? Well, first of all, we would like to see networks that are enabling lower CO2 emission, that are minimizing the rebound effects, that are having also an effect of emission reduction across domains where they are adopted and deployed, and that they have a higher energy efficiency. What I mention here is also the fact that there are many aspects that it's very difficult as of today to be able to quantify and qualify even, because we're still in a fast-pacing world in which technologies are happening in such a fast way that it's very difficult to assess their impact on the environment, on the society, on the behavior of the all individuals and organizations. But this will be essential if we really want to go towards a sustainable development of our society. Now, what is very important, we believe, in particular within the 6G ecosystem, is that we need to reach consensus on what are the key values that sustainable 6G networks will deliver in terms of environmental protection, in terms of societal aspects. And clearly, it is important not only to identify which are these values, but also how this value will be measured and assessed, and who's gonna enforce that there is a continuous monitoring and a continuous improvement along these lines. What it's good, we believe, is that there are many organizations today. Some of them are voiced through the 1.6G Association, and several standardization groups. In particular, I mentioned a few at ITU that are working on several aspects. There are many more, but what we believe is very important is that in all research and innovation projects, there is a clear and consistent way to take into account how to monitor and assess the effect that the technologies that we are developing will have at first, second, and other levels. What does it mean? The first order effect is typically related to the, let's say, carbon footprint, and it's associated to the ICT equipment and their life cycle. Then there are the secondary or second order effect kind of aspects, which concern what is the induced effect created by the use of ICT or non-ICT, of the use of advanced innovative 6G technologies in the wireless, in the ICT, and in the non-ICT sector. And finally, what are the societal and let's say more broader, also psychological effects that technologies can have on individuals and organizations? Now, what we did at Digital for Planet, we started working on these aspects, in particular on exploring what can 6G do for the society. So we gathered forces with several partners, and we want to be able with 6G for society to address the tension between parallel needs in terms of 6G technological developments. On the one hand, ensure performance objectives, and on the other hand, make sure that these technologies are embracing and respecting societal and sustainable values to be pushed forward. Among the core pillars for this 6G for society approach is that, first of all, there must be an ethics an ethical and value-based approach by conception. So policies and regulations cannot be left apart. They have to work very closely with technology developments to make sure that there is a common approach to this. Also, in order to avoid mistrust or fake information or misunderstandings in what the technology can do and how it can work for individuals and for the society, it's very important to engage from the very beginning in early adoption of these technologies different types of stakeholders, including user associations, including citizens, including non-ICT players. Because this is essential to overcome the lack of trust that there has been, especially in 5G times, between different societal networks. And this we have realized, especially in several countries in Europe, Switzerland was one of those, where fake news and negative campaigns against technologies have been driven based on false or misunderstood information. So in this respect, we believe that it's very important to also address this perception that there is no sufficient transparency or complete information about how the technologies work and how the technologies can impact our health, our life on an everyday basis. Clearly, this is a challenging project. It's a challenging venture, but we're just at the beginning of this journey. So if you stay tuned on the Digital for Planet channels, you will hear more about that. I would like to conclude saying that with 6G, we can and we must act now. Somebody said that during the early stages of technology development, when a technology can be controlled, not enough can be known about its harmful social consequences to warrant controlling its development. But by the time these consequences are apparent, control has become costly and slow. And this is why we believe we must work and act now. This is why I invite all of you that are interested to know more about our activities and to join our activities to land on our channels. And I'm looking forward to the discussion in case there are any other questions. Thank you very much.
Thanks a lot. Thanks a lot, Monique. Thanks for this very interesting connections between different societal and technological goals to bring us finally on the road to 6G. And with this, let's switch to our next speaker, Varnika Srivastava. So for a small explanation for the general public, we had a scheduled talk by Luis, but Luis could not join us for some conflicts with some other meeting that he had to attend to. And therefore, they very happily together organized Varnika to be here with us and to give us a talk. Thanks a lot, Varnika, to make it, to be available in such a flexible way. It's a pleasure to have you. So the floor is yours.
Thank you, Artur. And I'm very happy to be here today. I'll share my screen. So my presentation is on the 6G and whether it can be the game changer that can accelerate us towards achieving our sustainable development agenda of 2030 even faster. I would like to start with first giving a small overview about GESI. GESI is the only global membership organization for telecommunication industries and the ICT sector. And our primary goal, our target is to enable the ICT industries to meet their sustainability targets. We want to utilize the potential of digital solutions and then enable our members, our partners to address the most pressing of all environmental and societal challenges head on. And we bring together some of the largest and most ambitious of all ICT brands to be our members and then work towards this agenda. Our core values, our vision.
Varnika,
yes.
I'm sorry. Can you please switch to full screen, maybe? Maybe it's easier.
Yes.
Sorry, because we're still seeing the slides. I'm sorry for interrupting.
This in my screen, it's showing that it is slideshow.
Oh, yeah, I guess this is on the screen. Okay, fine. I'll just continue.
Oh, okay. So our core value and our vision, as I was saying, is we drive purpose-driven change. And we want to enable digital solutions for collaboration between industries, between the ICT sectors, to create value and lead the sustainability agenda of the future. So we create conditions that lead to these opportunities, and at the heart of all of our work is creating collaboration and fostering new relationships. Our working groups and our projects and work allow for people all around the globe to collaborate with us, and we lead the way for them to create positive impact on the world itself. Our members are spread out all over the globe, and we are very happy that they also contribute much to our projects, to our work, and they share our ambition of making the world, sorry for this very cliche saying, but to make the world a better place. Our concept of sustainability is multidimensional, which is related to environmental sustainability, economic growth, and social inclusion. And this is also shown in our thought leadership, which ties very well into the topic of today's discussion, which is about 6G and how it can be the game changer when it comes for us to realize and recognize our sustainability goals for 2030. So what has become clear in the past year and with the discussions that have been going on is that 6G technologies and their development can redefine how we live, how we work and communicate. It has the power to reshape our societies, and it is key to help us tackle the world's most pressing climate issues. And 6G can usher in new customers and new ecosystems, along with a diverse collection of connected devices, and in a cost and energy efficient manner. Through our, Jesse wants to highlight that green and sustainable development of 6G technology is a critical requirement now moving forward towards the 2030 agenda. And the progress and the advent of 6G wireless communication, it represents a significant milestone in our technological evolution and offers an unparalleled opportunity for us to foster sustainability and transform our world. And this comes with the technology that 6G brings with us through ultra-fast connectivity, through intelligent energy management and applications across various domains. And that is how 6G, it stands as a game changer in prioritizing sustainable development and how we can move forward. It opens, it's through our research, through our work, we have seen that 6G has the potential to open this door because it enables smart infrastructure systems to operate more efficiently. And it reduces resource wastage and energy consumption. These are some of the big topics that 5G networks and our current way of working does not address, which is something that we hope that 6G will be able to address very, very efficiently. Speaking of that, the energy efficiency, which is achieved through digitization, is critical for a more sustainable mobile industry because of the anticipated growth in data generation. 6G networks can provide the applications that need to make this happen. Around 135 countries and hundreds of companies worldwide have pledged carbon neutrality. The technology sector is poised to create long-term solutions towards environmental sustainability, and in particular, electronic design can support the development of clean energy system, data analytics for environmental applications, and machine technology advancements that reduce carbon emissions. And thus, since sustainability has become such an important issue for the telecom sector, topics like emissions and waste reduction are also coming up more frequently. And thus 6G and its implications on energy efficient become much more important. And much more at the center of our way going forward. It also, So the concept of, which is also something that we want to highlight through our Digital with Purpose movement that we have at Jesse, we work closely with initiatives related to smart cities. And the concept of smart cities driven by 6G connectivity revolutionizes urban planning and resource utilization. With real-time data collection and analysis, smart cities can optimize traffic management, waste management, and energy distribution systems that minimize environmental impact and enhance the quality of life for residents. Thus, by integrating various services and infrastructure, 6G powered smart cities can foster sustainable urban development while ensuring efficient resource allocation and reducing congestion. So I would like to now mention the question that I started with, the question that Jesse asked in the beginning of this presentation, which is 6G the game changer that we are looking for? And we think yes, 6G technology holds immense potential to transform our world, and it is a way through which we can prioritize sustainable development. As I have highlighted in the examples that I gave of energy efficiency, of utilizing 6G technologies in smart cities, through the fast connectivity, intelligent energy management, agriculture, smart cities, environmental monitoring, and healthcare, which I didn't get the chance to touch on. But 6G stands as a catalyst for positive change. And by harnessing the power of 6G, we can build a more sustainable future where resource allocation is optimized and environmental impact is minimized, and the well-being of both people and the planet is put in the priority and in the heart of what our key message should be. Thus, I would just like to conclude by saying that because it has such a big potential, it is crucial that policymakers, industries, and individuals embrace and also leverage the capabilities of 6G in order to attain the sustainable and inclusive society that we all are aiming for. And thus, this is the end of my presentation. And if you have any questions, you can ask them now.
Thanks a lot, Monica. Thanks to all speakers. So this so far concludes our main part with the talks. So now we had several very interesting Q&A section questions, which you can track back, right? So they have been answered. So you have different tabs for the audience. You can check how they were answered. And if you feel that they weren't answered correctly or not exactly in the way how they should have been, you can ask again. So simply write a new question, maybe referring somehow to something that was said before. And now let me open, so to say, the question section to all speakers. First of all, from my side, because we are a little bit low on time, so we have about 15 minutes left. So let me ask all speakers a very simple question. So obviously, we know that ICT can become a driving factor for other industries to improve in terms of sustainability. So decarbonization was mentioned also by Christian, just now by Varnika. Monica said it, obviously, it was also clear from Lupchus and Chiara's talks. So we all agree, we as ICT domain can be very useful for the others. But then again, since we are rather ICT people, I'm always, as technologist, interested in the question, what are the things that we can do to improve our own sustainability? The rationale of this is very simple. If everybody switches, to using more ICT, then somehow our share in the overall whatever carbon footprint or energy consumption will increase. So it makes sense then to think about how we can essentially do it. And so what I would like to ask every speaker is to give me exactly one, so to say, main conceptual direction It doesn't matter if you repeat what has been said, following which we as telecom industry can improve our own sustainability. Let's go in the same order as the presentations, please. So Chiara, you first.
Well, yes, these issues are basically the center of what I presented. So in my opinion, it's very important to have a clear vision of what is being consumed, clear figures to be able to know what we're optimizing. And one thing that just came to my mind while you were posing the question is that ICT is one of the biggest culprits for consumption. It's been for several years, and it will likely keep being that. But on the other hand, we've got also to keep in mind that if ICT increases its consumption, it might be also because its overall consumption is decreasing somewhere else. Many applications that are provided as vertical applications, for example, maybe were consuming energy in the physical sense beforehand. So this is one of the reasons why I think that it's important to have a concerted view involving as many entities as possible in the ecosystem, not only because we can all together improve our sustainability by helping each other, but also to have a clearer vision of what actually is this energy being consumed, where it comes from.
Thanks a lot. Christian?
Maybe building on what Chiara just said, I think it really starts with overall transparency so that we can actually see where we are aiming to and what we are achieving with whatever measures we take next. Energy efficiency, CO2 reduction, you name it in that regard, because it doesn't help us if we don't know where we stand right now, how fast it is increasing, or if we can actually keep it level. And also trying to figure out basically, what else are we actually enabling with it? Because driven by other requirements, we might be still good with the ICT domain in the end. Because we help to keep the others at bay. So it might be fine that ICT is still increasing its percentage in the overall footprint, but the others are slowed down. So that's something we don't really know by now, I would say. So that's why the transparency is key, and maybe not just following that road, but also trying to look in what we learned from other domains, like what I just shortly mentioned in the presentation. Not only looking in the provider side, and they have to react to whatever comes from us, from a consumer, from business side, and so on, but trying to put it into an equilibrium partnership with demand side management and learning from the energy domain. They deal with that already for a decade. That might give us good pointers how we can also establish the right pathways to use it.
Thanks a lot, Christian. Look,
yeah, I mean, a lot has been said indeed, and I agree with most statements. Maybe just maybe a bit naive, but very practical thing that ICT can do is just be transparent and educate the end customers. So why I don't get anything as an eco label of my mobile phone? I only can compare mobile phones on performance characteristics. Why I don't get this into my subscription that I have used so many X kilowatts per hour or CO2 emissions? What about your fixed network at home? For enterprises, the indoor networks, you name it. So why don't we just push this through and maybe even charge on it somehow? I mean, then that's a difficult area, but and then you become much more, I think, aware of the sustainability impact. Similarly, as for cars, you want to know how long they go on a battery, what is the distance, or electric appliances, how energy consuming they are. So in this area, I would say there is a lot to gain, maybe low hanging fruits, but it's not that easy. But I would be very happy if the industry is moving that way.
Thanks, Artur. Monique.
It's a difficult question. Well, it's difficult to give a plausible answer to this question, in my view, because clearly there are many unknown factors, and clearly ICT is a rather broad and generic term. But clearly, there are estimates that indicate that by 2025, ICT could consume 20% of the global electricity. And by the end of this year, it could consume it could generate 5.5% of the all CO2 emissions worldwide. You know, statistics or number changes ever, but just to say that it's huge. The potential negative impact. On the other hand, we know very well that our society and the development of our society will be driven, or it's intrinsically connected to this digital transformation. Therefore, the best way to go is, as I mentioned in my presentation, to try to address several challenges in an holistic and comprehensive way. We believe that we cannot solve it only wearing the ICT glasses on. That's the main point for us at Digital for Planet. That's why we want to have on board technologists, sociologists, economists, fiscalists, and you name it, because it's going to be depending on how quickly we can educate ourselves and the developers of the technologies, the better effect we will reach. So it's clear that ICT is in charge of driving the green digital transformation, but ICT developers and users must, and this is not an option, it's a necessity, must change the way they do things.
Thanks a lot. And Veronica.
Thank you. I agree with what Monique was saying, and also all the other speakers. Jesse also believes that recognizing what is lacking is, of course, it's key. Transparency is very, very important, but also the positive change can only come about through collaboration, through learning from other people's best practices and being open to make change. That's very important, because we have seen that there are companies, there are some actors who are not always willing to make the change because it's the status quo. We just need to be open to collaborate and learn. And then, of course, with technologies at 6G, they can be transformative, and we have to be open to embracing them in the best way possible to make positive change.
Thanks a lot. Yeah, amazing. I'm really amazed, guys, because in principle, if I can summarize it, what you pointed out is not some kind of strange optimization mechanism or super duper radio emission, avoidance system, but rather you said we need to get data, we need to make our systems more transparent, and we need to educate users, if I summarize it shortly. And you were kind of repeating the same message. So it's more important right now, and I think the literature also agrees with this, to get real measurement data, to get real numbers out there, to publish them, to get this transparency thinking, which is very different from what we were doing so far. Thanks a lot. And this brings me to the second question. So in terms of what we were doing so far, 5G, what did we do wrong? In terms of, 5G, I'm taking for 5G right now the global mobile system standard, right? So I'm not talking, because you can talk of 5G in general, let's say, service chain. But if we limit ourselves for a moment to 5G as a global mobile telecommunications standard, where did it fall particularly short in terms of sustainability? So in other words, what should the next standard, the successor 6G, do better? Please, in the same order. Yeah.
Well, I've been quite harsh with the 5G and 5G related technologies in my talk. So for a change, I would like to give them a break for a little bit, because in my opinion, the main issue has been that lots of breakthrough technologies were involved in 5G. I mean, when we did the projects on energy efficiency in the 2010, when the EcoNet project was financed, for example, we had the same architectures for I would say 20, 30 plus years at that point, with changes, of course, in protocols and so, but the infrastructures were basically the same. So we knew very well what we were playing with. Then there was big paradigm shifts all at once. And so there was some naivety probably about their impact in the beginning, as I said before, but we lacked the knowledge. We didn't have that past expertise like we had before, and everything was new. So that's what makes me hopeful for the future, because now we are aware of the impact. We've got the tools, we're developing the tools to be even more aware and to have a clearer vision at different levels. And I see that also the panelists are on the same wavelength. So I see that this is a widespread opinion. So I'm quite optimistic moving forward that the knowledge that now we have will drive us to do better in the near future.
Thanks a lot. Christian.
Yeah, but also say it's a part of a learning journey, which in regard of a B2B business, I kind of just started with 5G. So it maybe wasn't that easy to expect the industry already to being fully involved, to fully understand what this new level, what that new technology brings for change, and basically being a kind or part of the harbingers, bringing hyper connectivity, all these data-driven services, platforms, and so on, also to each domain we can see at the moment. Because we weren't there when the standard was first conceived. So there wasn't the interest, so it just went, let's call it the normal way, via the free GPP in the 10-year cycle, and then at a later point, industry, and just to a very small percentage, got interested and started participating already. So we start to see it with the releases coming out now, that there's more and more industry requirements already in it from different domains. And I think with 6G, we can start it differently from the very beginning, building on what we have now with 5G and also the intention we have across the board. I think can make a big difference to actually design a standard to what it needs to be from the run, directly from the start when it comes out in the final release. And that it hopefully also caters one of the big problems we see also across the board, interoperability. As shown before, between the different technologies, between the different platforms. And if it can just help to a certain amount, I think we lose a lot of friction, which also helps us a great deal, as we said, with the transparency and hence sustainability.
Thanks, Christian. Guys, we're running slightly low on time. Thanks to the audience for being patient with us. Maybe, Lucio, a little bit shorter way, but still.
Okay, yeah. Where this 5G is falling short on this sustainability and energy efficiency. Yeah, it's difficult to pinpoint on a particular topic, but I would just say kind of still in the design phase. It wasn't a target, this kind of sustainability and energy efficiency, but somehow with the implementation and the standards, we are now catching up, but there is still some kind of inertia in the system that you cannot really react quickly to the traffic demands, and you are not optimally using your energy resources. And I think now we are seeing around the corner coming up this kind of tuning between like what kind of quality you want to have versus the impact you have on the CO2 or energy consumption. So maybe we are catching up slowly but steadily.
Thanks, Lucio. There are still some open questions in the QA. Maybe you can try answer them, all of our speakers. And Monique, you're next.
Just wanted to say something. Well, you asked what we did wrong in terms of 5G. We still have to see 5G happening in a way, in many ways. So I think there is still a chance for 5G to help us addressing many of the problems that we're targeting today. What clearly went wrong was a mix of aspects. Let's say, think too late about sustainability or neglect some of the core aspects related to, energy consumption and at the end, digital pollution, mixed with a lot of misinformation that was circulated. So let's hope that this time we can do it better by engaging people, by explaining them that thanks to technologies like 5G or 6G, you can get a brain operation in a remote way and save people and do amazing things in terms of, also saving lives, not only in terms when disaster occur and so on and so forth. So I think it's really, that's why I keep on stressing the fact that it has to be a multi-stakeholder approach. This time we cannot miss that train.
Thanks, Monique. Monica.
Definitely learning from the mistakes of 5G is important. 6G is still very much new. We are still researching the potential impacts and what it could mean. And one thing that we didn't fully realize when we were deploying 5G, but we have a significant head start with 6G is that we can already learn from the mistakes that 5G made and approach 6G in a much better way. For example, incorporating the circular economy approach right from the very, very beginning, which would mean that we emphasize sustainable design or recycling, reusing components, devices from 5G, making sure that the components have easy repair and modular upgrades. And one thing that we should definitely keep in the forefront of deployment of 6G is definitely ethical and sustainable supply chains. So establishing transparent and sustainability in the supply chains, responsible sourcing, and also focusing on minimizing the environmental and social impacts. It's a very long journey. It seems very difficult, but it's already a big step that we have recognized all of these potentials where we can improve, and I think we are taking the first step, so we can learn and then hope for the best, I guess.
Thanks to you, Monica. Thanks to all of you guys. Thanks for the answers. So I guess this last one can be summarized as we have still to learn something because 5G is somehow not yet there. It's still being deployed. So we have learned. And we will continue learning from what was done and how it was done in 5G. Not everything was wrong, but we simply probably lacked some knowledge about some of the technologies which are new, which emerged with 5G. Thanks a lot. And then by taking everybody on board and avoiding these errors and starting this from the very beginning, maybe we can get a better 6G standard, right? If I can summarize it like this. Now, guys, this closes our major session. Maybe thanks a lot to all speakers. And just a small announcement from our side, from 16G, please bear in mind, we will have the 16G Summit 2023, so this year, entitled Empowering Vertical Digital Revolution Through Global 6G. So important keywords here, global 6G, one single standard, we always stand for that with 16G, and vertical digital revolution, what is this, what is it supposed to be? Please save the date, it's 9th to 10th of November. This year in Munich, in Germany. You can have it as a face-to-face event. I think it's an event not to miss for sure. Thanks to all the attendees. Thanks to all the speakers. And this closes our open lecture number 6, Sustainability in 6G. Thanks a lot to everybody. Thanks to the organizers from Martel. Thanks.